class. Today we're going to learn about writing equations of parallel and perpendicular lines. So let's take a look. How can we get an equation of a line parallel is where we'll start. Write an equation of the line that passes through this point and is parallel to the line y equals 3x minus 3. So what we know about parallel lines is that they always have the same slope. So if we take a look at this line here, the slope, right there, 3. So what do? We go ahead and we write our slope would have to be 3. And our line will go through the point -3, 5. So there's our x and our y. And we all know how to use slope-intercept. So we write y equals mx plus b. And we write y equals mx plus b. And the first time we're looking for the y-intercept. So what do? We plug in y, 5, slope 3, and -3 for your x plus b. So we get 5 equals 3 times -3 is -9 plus b. And we add our 9 to both sides so that we can get a 0 here. Add 9. And so we get 14 equals 0 plus b, so it's just a b. Now we plug in. We have y equals, our slope is 3x, and our y-intercept is 14, positive, so we write plus 14. And voila, we have an equation that's parallel. Now, I want you to notice something here. The original line, let me see if I can get my eraser. The original line is y equals 3x minus 1. Our parallel line is y equals 3x plus 14. Compare them. The slope is exactly the same, but the y-intercept is different. That way these lines can fit in different places on the graph, but have the exact same slope. All right, let's move forward. I would like you guys to try this equation. Write an equation of the line that passes through this point and is parallel to the line y equals -1x plus 5. So notice the slope here is -1. Use that for your slope of your line that's going to be parallel, and it goes through this point, x and y. Pause your video, give it a try. Welcome back. Let's take a look what you should have had. Let's take a look at this. Y equals -x plus 9. Look at the original equation and the new equation. They're identical except for the y-intercept here is 5, y-intercept here is 9. All right, let's take a look at another type of problem. What happens if they ask you to determine which line, if any, are parallel or perpendicular? Well, parallel lines, you recall, have the exact same slope as each other. Perpendicular lines will have the negative reciprocal. All right, let's take a look. Line A, our slope is 5. It's right there, it's obvious. All right, now we have to figure out the slope of line B. So I'm going to grab a pen real quick, and I'm going to rearrange this to get it in the slope-intercept form. So I'm going to subtract my x and subtract x. So I get 5y equals -x plus 2. Divide everything by the 5 so we can have a single y. And we can put a little tiny 1 in front of that, so it's -1/5 x. So this slope is 5 for this line. The slope for this line is right here, m equals -1/5. This line and this line are perpendicular. How do I know? Because 5 for the slope could be written as, 5 over 1. Flip it. This one's positive, this one's negative. They're opposite in every way. That makes these two lines perpendicular. Let's take a look at line C. We're going to rearrange it to get it into slope-intercept. So -10y equals, add your 2x, add 2x, so we get 2x on the other side. Divide by a -10, divide by -10. So y equals a -1/5 x. These two lines have the exact same slope. The slope on this line is -1/5. So these two lines will be parallel. This one will cut off the y-axis at 2/5. This one will cut off at 0 because there's nothing over here. All right, so lines A and B are perpendicular, B and C are parallel. I would like you guys to try out these three lines. This one's always in slope, already in slope-intercept, so there's your slope right there. These two, you're going to have to rearrange. They have the same slope, but they're parallel. If they have negative reciprocals, opposite in every way, they're perpendicular. Pause your video and try it out. Make sure you show your work. All three of these lines should be written in slope-intercept when you finish to be able to identify the slope. All right, welcome back. Let's see how you guys did. You should have been able to find out that B and C are perpendicular. I'm so sorry. Let me correct that. Parallel, B and C. Perpendicular are A and B. And A and C. All right. Let's give it one more time. Is line, oops, I skipped a, sorry about that. Let me see. Is line A perpendicular to line B? You just have to rearrange these in the slope-intercept, and you would find A is negative 1/2 and B is 3/2. They are not opposite in any way. They're not the same, so they're not parallel or perpendicular. Neither one. All right. Oops. Let's take a look. Write an equation of a line that passes through 4, -5 and is perpendicular to this line. So real quick, we have a slope of 2. Perpendicular line would flip that upside down, so it's 1/2 and it's negative. So we would use the x, the y, let me grab my pen. They would use this point since it goes through this point, and this would be our slope. M equals negative 1/2. Notice the slope on this line was m equals 2. The word perpendicular would indicate these have to be opposite in every way. Since this is technically 2/1, we flip it. This is positive, this is negative. Then we type it into slope-intercept. We write y equals mx plus b. And we plug in our y value, which was -5, getting it from here. And slope, negative 1/2. And our x value is 4, plus b. What's half of 4? Well, that's 2, -2. So we have -5 equals -2 plus b. Add 2, oops, 2, add 2. So we get -3 equals b. So we have y equals, slope is -1/2, and then a -3 at the end. Here is an equation of the line that goes through this point with this slope perpendicular to this line. All right, one for you guys to try. Pause your video. I would like you to write an equation of a line that passes through 4, 3 and is perpendicular to this line. Pause your video, give it a try. Welcome back. Notice that this slope was 4, so we need -1/4 for our slope. So we have y equals -1/4 x plus 4. How did we get the plus 4? We typed it into slope-intercept, or substituted, I'm sorry, and got that. That's it for tonight, and I'll see you tomorrow.